All right, so we want to now run our machine learning model on this data so it can predict for us a number that's not listed here that, if we have 77 claims, what would you predict the total payments were for 77 claims? So we're going to be training this data, and training, as the word implies, it has some trial and errors, and you're learning step by step, and so you're not good when you just started, and then you're getting better as you train, right? So step by step, you're training and you're becoming better, and then there's going to be a point where you say, you know what? I think now it's trained good enough. Let's test it now. Let's go live with this. Let's try it out. Let's see if this is going to work, right? So this process requires, I guess, two then different steps. One is training it, and then one is testing to see if it's trained now and it's ready to give us real predictions. I'm happy with the way that it's trained. Let me now go ahead and use it after I tested that it really is good. So there's two parts. Part one is training, and part two is testing and seeing that if the model was trained properly. So what does that mean with regards to our data set now? Well, that means we need to split this data set into two different sets. One set we need for training the model, right? Let's say like we'll give it like some of these numbers here. We'll say here, go ahead, train yourself with these numbers and crunch your numbers. And then after that, it crunches the numbers. All right, so it knows about this information now. Now I want to give it a new number that it hasn't seen before. So rather than me making up a number that's not real, I want to give it a real number that's that's really in part of the set that it's working with. It's part of the same things that it's working with. Let me give you an example of like pictures, right? Imagine you're training a child and you're showing that child different pictures of apples, right? You want to make the child distinguish between an apple and an orange. So you show a couple of pictures, you show the child a couple of pictures of apples, 5 pictures, and now you show also 5 pictures of oranges, and you tell them these are oranges and these are apples. Each one you say here, this is an apple, this is an apple, this is an apple, and then the other, this is an orange, this is an orange, this is an orange. So now what are you doing here? You're training the child, you're teaching the child about what an apple looks like. So in the training process, you tell the child, look, the apple has, this kind of color, the texture looks like that, right? You give it different features of the apple that can learn that, okay, this is how an apple in general looks like. And then in the orange also, you also show it this is orange, the color, the texture. So then after you think that the child now understood what the difference between an apple and an orange is, now what you're going to do is, are you going to show the child the same picture from the pictures that you were training or teaching that child from? No. Why? Because you don't want to test that child based on the actual picture. Because maybe the child maybe the child is saying that this is an apple when you show it an apple, but because it the child remembers that this picture, this physical picture that you're showing, I can see that, the child sees that this picture that I saw when the teacher pointed at it, she said apple, and that's why the child says this is an apple. The child didn't maybe really understand the features that an apple has. So what does that mean? Meaning that when can you really know that the child understood that what's in this picture is really an apple or an orange? Well, by giving the child another picture that child never saw before. It's going to be closer, it's going to be close to the features. It's going to have the same features as the pictures that you showed that child before, but it's not going to be exactly the same. It's going to be a different orange. Either the background might be different, or, it'll have a little bit different texture, a little bit different shape, but it looks like an orange, where if you'd know what an orange is, you would say that this is an orange. So then you show the child another picture of an orange or an apple, and then you tell her, okay, what is this? Now, if she says orange for an orange, and then you show her another picture of an apple and she says this is an apple, so that means that child understood what is an apple and what is an orange. But if she starts getting confused, so then you'll say that, oh, that child did not understand what really an orange is or an apple is. Could be for different reasons. Maybe the child, like we said before, kind of overfit the definition of an orange, meaning the child was focusing on the picture, the actual picture that you're showing that child. Meaning they're not focusing on the attributes and the features and how does an orange look like and how does, what is the texture, the size. And she wasn't, or he wasn't focusing on the features. They were just focusing on the physical picture. So it kind of overfit. This is called overfitting. It's just looking, okay, this is an orange because the child is remembering that this picture, when it was put in front of me, was an orange or it was an apple. So what I'm trying to get at here is not making this any longer. And kind of, made it a little bit lengthy because we're going to be, dealing a lot with testing and, test and training sets, and we need to know why we're using them. So we're going to need to split our data here also into a test set and a training set so that we can give the machine learning model the training set so it can learn from it. And then when we want to now test and see that, hey, okay, did you really understand this? Did you understand what we're giving you? Are you going to be able to predict this right? Did you overfit, meaning did you start looking too much into the details of what we're giving you, or did you understand the overall, what are the features that we're looking for and how you can predict based on those features, not based on the actual numbers that we're giving you? Don't be stuck on the numbers we're giving you, but rather look more in a general form. I want you to fit the model to fit more examples later on that you haven't seen before. So we'll see, okay, I'm going to give you now a test set to test you and see, did you overfit? Did you underfit? Did you get things right? Are you predicting close or not? So then that's when we're going to give it the other part of the data set that we had as a test. So let's see how this works here. Let's go ahead in our notebook and let's start commenting here. I want to learn also, how we can comment. Let's say here, let's say, import the libraries, and I'm gonna say here, you know, get the data set, right? And here, let's say now that let's split the data set into a training and test set. Okay, so all right, let's go ahead and do that now. How are we going to do that? We're going to use a library from Sklearn, right? And you're going to need to install this, by the way. If you don't have it, you're going to need to install it. And we already know that, how to install that. It's by, going into the Anaconda, console and saying saying conda install. And I believe the actual name for the for this library is scikit-learn, right? So um, what you're gonna do is you're gonna open up your Anaconda console, right? And then put in conda install -c Anaconda scikit-learn, and that will install it for you, right? If you press yes, it'll install it for you. All right. So after you get it and it's installed, by the way, you want to do this before you open up your Jupyter Notebook so that, when it loads with the newly installed library that you just installed it. Okay, so if you did this after you open the Jupyter Notebook, let's close the Jupyter Notebook, install it, and then open up the Jupyter Notebook again. Okay, so now we have this. So you can say now dot. Now if you press the tab, it'll give you different, your methods that you can use from the Sklearn. And the one that we're going to actually use here is called the model selection. And from there, we're going to import the train and press the tab, and it'll give you the different, well, here's only one with train, the train test split. Okay, we're going to use that. Now, how does the train test split work? I'll be showing you later on when we go in Spider. We'll be able to see the documentation for the train test split. But for now, what you do is you give it, you split the data. You split the X and the Y into two things, into a train and a test set. So from the X and the Y here, you want to split it to say that, okay, give me some of this, give me some of this to be for the training. And usually you want the training obviously to be more, right? So it can learn more. And then you'll say, okay, and then take these as the test so we can test it and see that if it really learned or not. Okay, so we're gonna say first you give it the X, right? The training set for the X and the training set for the Y. So we're gonna say X train and, or actually, I'm sorry, we're gonna say it's gonna be both X's, X train and X test. So is going to give me, it's going to return from the X, and from, it's going to return from all of the X two things. It's going to split it into a X train and a X test, right? And then we want to do the same thing with a Y. So we're going to say Y train and Y test. So equals to. So when I say equals to, now we know there's going to be four things returned here. Whatever function is going to be running over here is going to return four things. It's going to return a set of X train and then X test and then Y train and a Y test. All right. So which one is going to do this for us? And which method is going to be the train test split. And then you give it the actual X and the Y that you want to split. So it's going to split this into two, put some here and some here. It's going to split the Y into two. It's going to put some here and some here. Now, what is the proportion that you want to put? Like how much do you want here versus the test? Well, you tell it by saying test size and the size that you want. We'll say, let's say, okay, let's make it 1/4, right? So we'll have 1/4 of the data, so, 3/4 of the data will be training and 1/4 will be the test, because I'm saying what is test size you want. So I want only 1/4 of the Y and 1/4 of the X. Okay, good. So then another thing that I just want you to do just for the purposes of this this exercise is to say random state equals to 0. This is another argument that you can give it here, so that it can always give you the same rows and the rows for the X and the Y. Because if you don't say random state equals to 0, you see how it's splitting the X into 1/4. So it can actually do it in random. It can just say take one from here, then take one from here, then take one from here, and then until it reaches 3/4 of them. And then for the test, it'll take the rest as 1/4. But now, because you want to get the same results when you do what I'm doing, you don't want random numbers. You want to see the exact same numbers that I'm using. So let's not say random, right? Okay, so you'll see this right now, and let's run it. Okay, very good. Now, if you say X train, you'll see here are the values for the X, and you'll see that it's 1/4. And if you say Y train, you get the same thing and the same thing for Y test. That's 1/4 of it. Very good. So now you have four variables that you'll be working with. And now when you're going to be setting up your model, you're going to be using all these four variables for the training and for the testing. And we'll be doing that in the next video.